Hello 8th graders. In this IXL support video we're taking a look at assignment F9, which is called division with exponents. And again, kind of like F8, we're going to review the rule first, or the property for division with exponents that makes this assignment pretty easy once you get that property or rule understood. I've got an example here. We're going to have, for this, like you suspect, they're going to have division with the same base term that involves exponents, and I want to prove the rule first with us. If they had given us something simpler, like x to the fifth divided by x squared, we would know that would mean 5 copies of x in the numerator divided by 2 copies of x in the denominator. And any number divided by itself cancels out or just becomes 1. So here we could go ahead and, in 1 second, strike out 2 of those x's, because 2 of the x's in the numerator will be canceled out by dividing by 2 copies of x in the denominator. Those will just make 1's. And left over at the end of the day, what we see here is we have 3 copies of x left on the top, or x to the power of 3. That's all that's left over. And I realize I could have gotten here, I could have skipped this big long step by just doing the numerator's exponent, 5, and subtracting the exponent in the denominator. Effectively what happens whenever I divide by the same base as is in the numerator, each copy in the bottom will cancel out 1 copy on the top, and that's why we end up just using subtraction. That would have been an easier way to get to x to the power of 3. So that tells us, and we're going to review this rule very quickly from our notes, it tells us that whenever you divide exponents that have the same base, all you need to do is subtract the exponents and then keep the base the same. If you have x to the power of a, let me zoom in a little bit, divided by x to the power of b, it's really just saying x to the power of whatever a minus b would equal. So we're going to use that rule a little bit. And in the first problem, we're also going to combine it with our power of 0 rule, which says anything to the power of 0 must be 1. And here's more proof of why the power of 0 rule works. This is 481 to the power of 7 divided by 481 to the power of 7. Some of you might be saying, hey, that's the same thing, Mr. Doherty. The numerator, denominator, same base, same exponent, and anything divided by itself equals 1. Other people, and we'll put this in red, maybe thinking, they say, hey, wait a minute, if this says 481 to the power of 7 divided by the same base, I could just do the top exponent minus the bottom exponent. Every 481 on the bottom will cancel out a copy on the top, and 481 to the power of 7 minus 7 really says 481 to the power of 0. But I know anything to the power of 0 has to equal 1 from other proofs that we had earlier this year, and this is actually more proof here. When the multiplication rule worked, we see, wait a minute, this number was divided by itself, it must equal 1, and that's why we ended up with 481 to the power of 0. As Josiah told second period, power of 0 just means the base is divided by itself. That's what we saw here, and that's going to always equal 1. I'm going to try putting my answer in as 481 to the power of 0. Mostly because I'm curious if they take that as an answer or they expected me to put the answer 1 in. And they do call that correct. I think they would have taken 1 as well. Now, some other examples that we see here. 186 raised to the power of 6 divided by 2 copies of that same base. I can simplify this. I don't have to write out all those 186's and cancel them out. I can just do 6 minus 2. The numerator, 6 copies, is going to lose 2 of those copies when divided by the same base. And that's going to be down to just 4 copies when I do 6 minus 2. So again, using that numerator minus denominator exponent rule in order to simplify division of the same base. Now some of these will start to get complicated. We do know negative exponents exist from F6 and F7, and when you have the division rule, you can certainly see negative exponents come up. So we have 445 as a base, and we're going to be doing 6 minus 7 because we have 6 copies on the top divided by 7 copies on the bottom. And 6 minus 7, you may recall from last year, that's going to be a negative number. That's going to give us the power of negative 1. So if I use my division rule for exponents, it says take the top, subtract the bottom. But when the bottom has more copies than the top, I end up with a negative number. In this case, a negative exponent of negative 1. And they said here I can't use negative exponents. I need to use positive ones. So really they expect me to also know that this is the same thing as 1 divided by 445 to the first power, or just 1 copy of it. And we can see this here. There was 1 extra copy of 445 on the bottom than the top, and that's kind of why this ends up saying 1 over 1 over 445 to the first power. So we're going to have to use a fraction to enter this. I put a 1 in the top. I click down to the bottom. I don't need to write that exponent here. I could go ahead and put a positive 1. I'm not sure if IXL is going to mark me wrong. That's kind of unnecessary, but I'm going to put it anyways to see. Cool. Next one, much more straightforward. And there's IXL for you. Give you a tough negative 1, and now all of a sudden they give you one that's easier. But I would encourage you to pause this video, think about if the base is the same and we're dividing, what exponent's going to be left over. And here in this case I'm going to be doing 8 copies on the top divided by 3 copies on the bottom. Each one cancels out, so I take 3 copies away. And that tells me 282 to the power of 5. Using Shift 6 to bump up to my exponent to save a little time, typing in that exponent of 5. Alright, we're going to pause the video for a second to encourage you to do that and figure out an answer to this one. If you have 788 as your base, 5 copies on the top divided by 7 copies on the bottom. Use our rule, think about what do we get for an answer. And this one is trickier. Now as you're coming back, hopefully knowing the answer, I'm going to go ahead and figure out 5 minus 7 is going to give me negative 2. So I know the base is 788, but I need to do 5 minus 7 there. And I get a negative 2. The base stays the same. I had 788 as my base, a bunch of those terms in the numerator and denominator. But there's 2 more in the denominator, or I'm going to get a negative 2 for an exponent. That really means I can't write a negative exponent according to IXL for F9. They want it as positive exponent, so I'm going to have to convert 788 to the negative second to a positive exponent by recognizing that just means divide by the 788 2 times. And again, using my mouse to click around after I built that fraction, dropping in the exponents by either using Shift 6 or that exponent button. We think number 1, you're good to stop this video now and work through F9 on your own. I would not keep watching unless you got stuck on a challenge problem or something like that further ahead. We're now in the part of the video where we're jumping towards those more difficult problems, whether they're in the 60s, 70s, or even up in the challenge zone. But it looks here like all they're going to do is give you more numbers or larger numbers in the exponent. It's still division of the same base. I'm still going to be doing in this case 395 is the base. Doesn't change numerator, denominator, same base. So I'm just going to be doing 67 minus 1. And I know they're calling this a tougher level, but I don't think this problem's really much tougher than anything you've done so far. You get 66 there. Sorry that almost looked like a negative sign with 395. And I think you all were good and ahead of me, and you're like, yeah, Mr. Doherty put that answer in, it's 395 to the 66th power. I'm going to skip ahead one more time to see. It looks like there are no other challenge zone problems. All they do is they give you larger base numbers, larger exponents, but use the same rule. So hopefully at home you're just doing 24 minus 1. You're saying, Mr. Doherty, you don't need the video anymore. We got this, and I agree with you. 374 to the 23rd. That's the last one we'll do together. Thank you for watching to the end of the video. Thank you for the great work pushing forward through F9 and all the ones that come after. If you do have any questions, as always, please feel free to email me. That email is on the screen. It's ddoherty3, and as usual at bostonpublicschools.org. Have a great day. Thank you.